first video on electrochemistry. So this is electrochemistry part 1 video. So I would like to go through the introduction to electrochemistry. First of all, I would like to give you idea about the some important discoveries and important theory that has been developed to make this subject. So first work by Louis Galvani in the 16th century uh, gave the birth to this subject. He did a beautiful work where he used two dissimilar metals and he produced an electric current through it. The two dissimilar metals, when brought in contact with each other, the electrical potential difference that is set up at the junction because of the different ability of metal to get oxidized and reduced, there is this development of electrical potential difference, and that electrical potential difference allowed the movement of electrons and which induces electric current. And this was further tested using an animal tissue. He basically did with a frog, and he noticed the shock, the vibration of the electric shock. The electric shock was experienced, and he concluded that this phenomena as an animal electricity. He thought that the animal was responsible for this kind of phenomena. But Michael Faraday, who did more research on this electrochemical reactions, and he further showed that it's not an animal tissue which is responsible, but it's the nature of the metal which is responsible for development of this kind of current. And he was successful in developing the first human-made battery, which is known as a voltaic pile. Out here you can see there is a combination of metals. In between that metals um, he placed an electrolyte. Actually, the electrolyte was basically the cardboard which was soaked in a salt solution, which allows the movement of ions. And he was able to generate a large amount of current through it. And this work was published, and everybody started admiring this work. Out in this picture, he's demonstrating his work to Napoleon Bonaparte. And pretty soon, the Sir Humphrey Davy realized the potential of electric current, and he thought that why can't we use this the electric current to break the bonds in atoms or molecules. So he used this electric current, and he used this electric current to break the chemical bonds, to break the chemical forces, the electrostatic bond or covalent bond. He used this electric current, and he was able to isolate some of the metals like the potassium, sodium through his technique, which we now call it as an electrolysis. And he has given a birth to a new kind of subject through which you can purify some of the metals. So yeah, he understand the potential of electric current, and he applied to chemistry, and that was the time where the physics and chemistry merged into each other and developed this field of chemistry, what we call today as an electrochemistry. And Michael Faraday, who could quantitatively study the work of Humphrey Davy, that whenever there is this process electrolysis occurring, you could uh, you could know the exact amount of current, how much amount of current you should supply to uh, to to quantify the amount of product, how much amount of metal is deposited in particular electrode. By using Faraday's laws and his equation, you can calculate the amount of metal that is deposited at particular electrode when you supply a fixed amount of current. So this quantitative relationship was studied by Michael Faraday, and the first primary cell was developed by John Daniel. The Daniel cell is very much common to everyone, and about Daniel shell we will learn about its construction, the types of metal electrode he used. Basically he used zinc and copper electrode dipped in a different solutions, and it was one of the historic moment of uh, historic achievements, that the first primary cell was developed. And the finally the people like uh, Nernst has developed the mathematical relationship to understand the variation of electrochemical cell potential when you vary the concentration of the electrolyte. So mathematical relationship between the cell potential and the concentration was studied by Nernst. And all these people's work has given birth to this new chemistry that's known as electrochemistry, and it has been widely used because it is one of the most developed and successful theory of all times, and it has wide range of applications in our real life. When you look around the objects that placed in your home, your workplace, wherever you go, you see these batteries. Like, battery is the important part of electrical devices. It is a powerhouse of most of the electrical devices. So it is based on the technique of electrochemistry. It is based on the principle of electrochemistry. And this is also one of the important advancement of human being. Developing an electric car, you can see a cable here used to charge a car. So during this charging process, the battery, which is an electrochemical cell, which work as an electrolytic cell, and when you are discharging it, when you are running your vehicle, at that time the energy stored in a cell is being used. At that time it works as an electrochemical cell. So basically it works on the two principles of electrochemistry. One is by releasing the energy, and another is by observing the energy. And in the open air also, there are lots of phenomena going on, like oxidation. When metallic surface is exposed to air, it absorbs the oxygen from the moisture and it gets oxidized. So the result of oxygen is this colored coating at the metallic surface, what we call as a corrosion. So this reduces the strength of metals. So whenever the metals that are used to make bridges that get old enough, so its strength reduces, and it becomes prone to uh, breaking of the metal. And another technique which is commonly used in most of the industries is called electroplating, where electroplating is just protection of a metal by other metal which is less reactive in nature. So it's a simple technique. We'll learn about this in our next videos. And in human body also, the transport of ions in the cell creates a small electrochemical cell, and this electrochemical cell develops an electric current, and which is necessary, which is important to send a signal from one body part to the brain, different body parts to the brain. The signal is sent from different body parts to the brain by this development of electrochemical cell through the transport of ions. So you can see the applications of this science everywhere, in right from the battery, the cars, metal industries, human body. So it is one of the successful theory ever developed by a human being. So now let me talk about the defining definition of electrochemistry. So electrochemistry, if you see the word itself, you fragment the word, then you can say that it's a combination of electro and chemistry. The electro word comes from the electrons, and the chemistry, as you know, it's basically related to understand the chemical reaction. So whenever there is a chemical reaction which involves the movement of electrons, so this basically comes under the branch of electrochemistry. So it's a combination of the the movement of electric current, and the study of electric current, the charges, and the chemical reaction. So in simple ways, if you define it, it's a branch of science which deals with the study of relationship between the chemical change and the electrical work. Now, when we talk about chemical change, you're talking about chemical change. That means you're talking about chemical reaction. So what kind of chemical reaction? So the chemical reaction that you are that basically is important to understand this kind of this kind of chemistry is the what is known as the redox reaction. We'll talk in detail about that. It's basically, there are two kinds of chemical processes. You can say it as an spontaneous or non-spontaneous. So what do you mean by spontaneous? So spontaneous means the process which occurs by its own ability. So it does not require any external agent to work under it to make something happen. So it basically works with itself. The energy for that is generated by its own potential. So that it has the ability to develop the energy by itself, and it transforms one form of a substance into another form of substance. You can take an example of oxidation of metals. So when the metal is exposed to an air, it undergoes oxidation, and at the surface there is a development of coating of the metallic oxide. So that is one type of spontaneous process, because you does not require any kind of external forces. Someone is not pushing the reaction, right? It's occurring by its own nature. And another kind of chemical process is non-spontaneous process. So these are processes which does not occur by its own. It requires some external agent to undergo this kind of process. And the non-spontaneous process, if you take an example of like a mobile phone battery, right? When the battery is zero, it does not work of its own. You need to charge it. So the charging process is, what you are doing in charging is that you are supplying energy from the external source. So that external source is helping to recharge your battery, and battery works. Again, working is a spontaneous process, and the recharging of battery is a working is non-spontaneous process, and the recharging is your non-spontaneous process. And based on the spontaneous and non-spontaneity of a reaction, there are two kind of cells. The cell chemical cell, where the chemical change releases free energy as a result of spontaneous redox reaction to produce some electrical work. So one type of cell is the cell where the energy from the spontaneous redox reaction is released, and that released energy is converted to some electrical work. So you can use that electrical work to light a bulb, to do some external work. And this redox reaction we'll learn about after some time. It's just simply the reduction and oxidation occurring simultaneously. And another kind of a cell is that where you supply a energy from external source, the source of electricity or whatever, to drive non-spontaneous reaction. So when you want to undergo chemical change for a non-spontaneous system, you have to apply the energy from the external source. So external force is necessary to drive a non-spontaneous reaction. So based on the spontaneity and non-spontaneity of a process, there are two kinds of cell. One cell where the chemical change releases energy from a spontaneous redox reaction to do some electrical work, and another type of cell which absorbs energy from external source and drive a non-spontaneous reaction. The delta G out here means the change in free energy. It's the measure of the energy change of a reaction, particular reaction. It's a thermodynamic quantity which measures the energy change of a reaction. If the energy change during the reaction is negative, then it's called spontaneous because it has released energy. If the energy change during the reaction is positive, then it is called non-spontaneous reaction because it is absorbing some of the energy. And next thing is this the battery that you know in this is mostly present in most of the automobile engine, in the car battery, and this is the battery which is used in mobile phone. The battery operates via two mechanisms. There is spontaneous process occurring in battery, and non-spontaneous process is also occurring in a battery. The spontaneous process occurs in a battery while we are using it. When battery has a certain amount of charge, it operates by its own mechanism. And when battery charges goes down and you need to recharge it, so that recharging process is a non-spontaneous process. So battery releases free energy due to spontaneous chemical reaction during the process of discharging, and it absorbs free energy from the source of electricity during the process of recharging. So battery is a simple device which works on two mechanisms of electrochemistry, that is the release of energy and absorption. So when you talk about a redox reaction, it's simply the word redox itself says it's a combination of reduction and the oxidation occurring. It's a chemical reaction where reduction and oxidation occurs simultaneously. We have been defining from fundamental classes, from elements like from class 10 itself. The reduction is a process where there is addition of hydrogen, removal of oxygen, and oxygen is a chemical process where there is addition of oxygen and removal of hydrogen. But in electrochemistry, we need to define the reduction and oxidation in terms of gain or loss of electrons. So reduction simply means the gain of electrons. When the particular metal ions gains electrons, its oxidation state decreases. What happens? Its oxidation state decreases. So during the process of gain of electron, the oxidation state of a metal decreases. And during the process of oxidation, the metal loses its electrons. So as the metal loses its electrons, the oxidation state is increased. So gain of electron is simply reduction, and loss of electron is oxidation. So to carry out this process, we need two kinds of agents. One is called a reducing agent. Reducing agent are those agent which reduces other and itself gets oxidized, because in a chemical reaction two processes are occurring simultaneously. One is getting reduced and other is getting oxidized. So reducing agent reduces other and itself gets oxidized. And similarly, we also have oxidizing agent. Oxidizing agent actually oxidizes others and itself gets reduced. So redox reaction is simply the combination of reduction and oxidation, and you need two different agents, reducing agent and oxidizing agent. In electrochemistry, we basically deal with the transport of electrons. So gain or loss of electrons should be the suitable way to define redox reaction in electrochemistry. So we'll understand how to balance redox reaction. So redox reaction can be balanced by two methods. One is called half reaction method and other is called oxidation number method. These are two important methods which we use to balance redox reaction. But in electrochemistry, where we have two different cells, in one of the cell the oxidation is occurring, in another of the cell reduction is occurring. So it is suitable for us to balance balance this redox reaction using the half reaction method. So half reaction method is a simple method where we divide the overall redox reaction into two components, the oxidation half reaction and redox half reaction, and further we add the charges and atoms to balance, and further we add, and we also need to multiply. We'll see the steps in detail and what are the various steps involved to balance a redox reactions, how you can balance the half reaction. So first thing you need to do is you need to see the unbalanced ionic reactions. These are called skeletal ionic reactions. So you have to divide that into two half reactions. One is oxidation half reaction and another is reduction half reaction. So you need to identify this, which is oxidation half reaction and which is reduction half reaction. So how do you identify this half reactions? So I have given you a definition. You have to look at the loss of electron and gain of electron. Where there is loss of electron, you can simply say it's an oxidation half reaction, and where there is gain of electron, you can simply say it's a reduction half reaction. So first thing is you should divide the skeletal ionic reaction into two half reactions. And second, what you do is you balance the atoms and charges. So second step, what you need to do is you look at the atoms at the both side of the reaction. If they are equal in number, then no need to balance. If they differ by a number, then you start balancing them. And you also balance the charges, because according to the principle of electron neutrality, there has to be equal number of positive charges and equal number of negative charges in your system. So you have to balance the charge as well as the number of atoms. Why you need to balance number of atoms? Because it's in according with the law of conservation of mass, because mass can neither be created nor be destroyed in a particular chemical reaction. And third thing you need to do is you need to multiply with suitable integers if necessary. If you need to multiply with suitable, you multiply with either 1, 2, 3 or 4 according to your need. If by multiplying suitable number, if your half reaction gets balanced, then you have to multiply them, and you have to balance the number of electrons also in redox reaction in the reduced part and the oxidized part, because the number of electron that is transferred should always be equal to number of electron that has been accepted, right? Because the amount of electrons that is released by one of the system is equally accepted by other systems, so the number of electron has to be balanced. And fourth thing is that you need to add those half reactions and add the states of matter. So to add more information to your reaction, you add the states of matter, which state the particular ion or particular metal is in. If the metal is in solid state, you add solid. If the ion, basically ions are in solution, so we add aqueous. For water we add liquid. So this gives us information about your equation. And then last we check, and finally we check whether the number of ions are balanced, number of charges are balanced, and number of atoms are balanced or not. So finally we check our redox reaction whether it's balanced or not. And I'll show you one example how to balance redox reaction in acidic solution. Mostly the electrochemical cell reaction occurs in acidic solutions. So I'll tell you how to balance these reactions in acidic solution by using all the 5 steps that I have just shown. So first thing is, what you need to do is, when you're balancing redox reaction in acidic solution, you need to always look for water molecules and H plus ions for balancing. So these two are very important. You look for water molecules and H plus ions for balancing the redox reaction in acidic solution, because acid is a substance which releases H plus ions in the solution. So you have lots of H plus ion in the solution, so you can use it to balance the your chemical reaction. Let's take a simple example of this kind of reaction where the dichromate ion and iodide ion in an aqueous solution reacts to give a chromium 3 plus ion and iodine in a solid state. So what you need to do is, first you need to identify the reduction half reaction and oxidation half reaction. So how do you identify it? You simply look at iodine. Iodine is in minus 1 state, right? It is in a negative state. So when iodine goes from this reactant to product, it is in zero oxidation state, because from the rule of oxidation number or oxidation state, the element or an atom which is present in its free state or its elemental state is always zero. So here the oxidation state was -1 and iodine came to the product with an which has oxidation state 0. So there is increase of oxidation state from minus to plus. From our definition, the increase in oxidation means it is an increase in oxidation state means it is an oxidation process. So in case of Cr2O72 minus, if you know how to calculate the oxidation state of chromium, don't worry, I'll just briefly explain it. And you know the each oxygen atom has an charge of 2 minus. So 7 has a charge of 14, minus 14. Plus you have 2 chromium. Let us assume that the chromium has an oxidation state of X. So 2 into X minus 14 will be equal to the overall charge of the system is 2 minus. So simply what happened? 2 into X plus minus 14 is equal to 2 minus. And when you calculate for X, you will find that the oxidation state of chromium is 6 plus 6. And when it undergoes a chemical reaction and when the product is formed, the chromium 3 plus ion is formed in the solution. So the chromium 3 plus ion out here, the oxidation state is plus 3. So that there is decrease in oxidation state of chromium from growing from the reactant to the product. So decrease in oxidation state means the reduction. So we identified the different half reaction. The oxidation half reaction is I minus to I2 and the reduction half reaction is Cr2O72 minus to Cr3 plus. So this is the reduction half reactions and this is the oxidation half reaction. Okay, now we are done with our first step, right? So now let's balance the number of atoms and number of charges for this chromium dichromate ion and the Cr3 plus half reactions, which is basically the reduction half reactions. So in order to balance this kind of system, what you need to look at is first look at the number of chromium atoms. So the atoms other than hydrogen or oxygen. So in the reactant side, there are 2 chromium atoms. In the product side, there is only 1 chromium atom. Forget about the charge, right? So this is there in reactant side 2 chromium atoms, 1 chromium atom at the product side. So straight away you know that you need to multiply it by 2. So you have balanced the number of chromium atoms. And next, what you need to do is you balance for oxygen atoms. So to balance oxygen atom, we add water molecules. So 1 water molecules can balance 1 oxygen atom. So you see in this reaction that there are 7 oxygen atoms. So how many water molecules you need? You need 7 water molecules. So the water molecules is also balanced. Look, these are not that tough. You just need to follow the steps. You have balanced the number of chromium atoms. You have balanced the number of oxygen atoms. And next you need to balance hydrogen atom. How do you balance hydrogen atom? Because once you have introduced the water molecules, there is also the hydrogen atom involved. So in above this reaction, there are 7 into 2, 14 hydrogen atom. So how many H plus ions you need? Why H plus ions? Because we are balancing in acidic solution, right? So you need H plus ions. So in order to balance 14 hydrogen atoms, you also need a 14 H plus ions. So you have balanced the number of chromium atoms, you have balanced number of oxygen atoms, you have balanced number of hydrogen atoms. Now what is left? The charge. You have to balance the charge. In order to balance charge, you add electrons. See, in the reactant side, 14 minus 2, because 14 positive charge and 2 negative charge. So it will be 12 overall positive charge. So in the reactant side, there are 12 overall positive charge. In the product side, there are 3 to the 6 positive charge. So if you subtract 12 minus 6, 6 positive charge is still left in the reactant side. So how do you balance positive charge? You balance positive charge by adding electrons. So you add 6 electron to balance 6 positive charges. Now you have balanced the number of chromium atoms, number of oxygen atoms, number of hydrogen atoms, and also number of charges. Now the overall reaction is balanced. So now let's try to balance our reaction for this oxidation half reaction. So in the oxidation half reaction system, the iodine which is in -1 state changes to the 0 state. So there is increase in oxidation number, so we call it oxidation. So you can see that there is one iodine atom, there is two iodine atom. So we just multiply it by 2 in the reactant side and the number of iodine gets balanced. So now next, there is no any oxygen atom, there is no any hydrogen atom, so we don't need to add the H plus ions or water molecules. We just simply need to balance for the charge. So out here there is 2 negative charge, and in the product side we multiplied by 2 electrons. So we add 2 electrons and you are now balanced for number of electrons. And then third step, what you need to follow is you need to multiply each half reaction to cancel the number of electrons, because see, in this kind of mechanism, number of electron that is released is exactly absorbed by the other system. The oxidizing system releases electron and the reducing system accepts that electron. So number of electron has to be equal. So in this particular case, there is 2 electron. In the reduction half reaction there was 6 electrons. So you simply multiply this oxidation half reaction by 3, we will get 6 electrons. Now the number of electrons is balanced. So now what we do is we add the half reactions and add the states of matter. So this is your reduction half reaction and this is your oxidation half reaction. Once we have added, you can see the number of electron gets cancelled, the reason to multiply with 3. And after that we add the states of matter. For ions, these are basically present in solution, we add aqueous because the water molecules has dissociated these ions. And for the this iodine I2, it's in solid state initially, water is for liquid, so we add state of matter to give more information to the reaction. And we have balanced the overall reaction and we have added the overall reaction. So this is the overall reaction that is taking place in a acidic medium. So we have balanced this chemical reaction by using our 4 steps. And finally we check for the number of atoms and charges. So basically there are 6 iodine atom in the reactant side, and also for product side there is 3 to the 6 iodine atom. And similarly there is 14 hydrogen atom out here, and again the 14 hydrogen atom is present in the product side, and 2 chromium atoms in the reactant side, and also we have 2 chromium atom in the product side, and we have 7 oxygen atom in the reactant side and also the 7 oxygen atom in the product side. And we have out here the 14 minus 6 is 8, and 8 minus 2 is 6 positive charges in the reactant side, and out here we have 3 to the 6 positive charges. So overall we have balanced the chemical reaction. So this is one of the easiest step to balance the redox reaction by using the oxidation half method. So you just apply this step and you can simply balance the redox reaction. Yeah, you can also balance the redox reaction in basic solutions, but in basic solution what you need to add is you need to add the hydroxide ion, the OH minus ions and water molecules. By following these steps you can simply balance redox reaction in both acidic solution and basic solutions. So if you have any problem regarding how to balance in basic solution, you can just comment in the comment section. You can ask your problems in comment section. I'll be free to answer you. So for further learning, just subscribe to our channel, the Funk Science Class, and thank you for your support. Thank you. Yeah, you can also balance the redox reaction in basic solutions, but in basic solution what you need to add is you need to add the hydroxide ion, the OH minus ions and water molecules. By following these steps you can simply balance redox reaction in both acidic solution and basic solutions. So if you have any problem regarding how to balance in basic solution, you can just comment in the comment section. You can ask your problems in comment section. I'll be free to answer you. So for further learning, just subscribe to our channel, the Funk Science Class, and thank you for your support. Thank you.